Imagine a place where gravity pulls so much that even light cannot get out. Such a place exists, and we call it a black hole. Black holes are fascinating cosmic anomalies, regions in space where gravity is so strong that nothing, not even light, can escape their pull. They're like invisible cosmic vacuum cleaners, silently lurking in the vast emptiness of space. Now, you might be wondering, how can we study something that's invisible? Well, even though we can't see black holes directly, we can detect their presence through the influence they exert on nearby objects, and through the diligent work of space explorations. When a black hole passes near a star or a cloud of gas and dust, its immense gravity pulls on and distorts the material, creating a telltale effect that astronomers can observe. Intriguing, isn't it? But that's just the tip of the iceberg. Let's dive deeper. So, how do these mysterious entities form? It's a tale of life and death, of stars. Imagine stars, not unlike our own sun, but much, much larger. Stars that are about 25 times the mass of our sun. These behemoths burn brightly, living fast and dying young, their lives culminating in a dramatic explosion known as a supernova. The supernova is a grand spectacle of cosmic proportions, outshining entire galaxies for brief moments in time. But the real magic happens in the aftermath of these celestial fireworks. You see, the core of the star, left behind by the supernova, doesn't just fade away. Instead, it continues to collapse under its own gravity. This is where the concept of gravitational collapse comes into play. Gravity, the force that keeps us grounded on Earth, becomes the architect of a black hole. The remnants of the star keep collapsing, the pull of gravity becoming so strong that nothing, not even light, can escape it. The mass is the same, but the volume gets smaller, making the density increase to unimaginable levels. The density gets so high that a deep pit in the fabric of space-time forms. We call this pit a black hole. It's like a cosmic drain, swallowing everything that comes too close. But it's not just a void, it's a place of incredible density, where the laws of physics as we understand them start to bend and twist. Black holes are not just destructive monsters, though. They're also creators. They stir up the cosmic soup, triggering the birth of new stars. They shape galaxies and challenge our understanding of the universe. They're the ultimate recyclers, taking in matter and energy and spewing out jets of particles and radiation. So black holes are like the ghosts of massive stars, continuing to haunt the universe long after the star's demise. Did you know that not all black holes are created equal? There are different types, each with its unique characteristics. Let's start with the smallest of the lot, the stellar black holes. As their name suggests, they are born from stars. When a star that is about 20 times larger than our sun exhausts its nuclear fuel, it can't resist its own gravity and implodes, creating a stellar black hole. These are typically about 10 miles in diameter, but don't let their size fool you. They can contain up to 20 times the mass of the sun. Stellar black holes are scattered throughout the galaxies, including our own Milky Way. Now imagine a black hole that's not just 20, but millions or even billions of times heavier than our sun. That's a supermassive black hole. These behemoths are found at the heart of most galaxies, including our own. The exact process of their formation remains a mystery, but one theory suggests they might be formed by the accumulation of mass over billions of years. Their diameters can be as large as the entire solar system. In between these two extremes, we have the intermediate black holes. They are less common and harder to spot, but recent discoveries suggest they do exist. As their name implies, intermediate black holes are medium-sized, with masses ranging from 100 to several 100,000 times that of the sun. Each type of black hole has different ways of interacting with their surroundings. Stellar black holes, due to their smaller size, can sneak up close to other stars and strip them off their outer layers. Supermassive black holes, on the other hand, can influence the orbits of stars and galaxies. Intermediate black holes? Well, they're still somewhat of a mystery, but who knows what fascinating secrets they hold. From stellar to supermassive, each black hole plays its unique role in the cosmos. Black holes, with their immense gravity, have profound effects on their environments. Let's explore some of these effects. Imagine a whirlpool, but instead of water swirling around, it's dust, gas, and other celestial debris caught in a cosmic dance. This is what we call an accretion disk, a mesmerizing spectacle of matter spiraling into a black hole, heated to extreme temperatures and emitting high-energy radiation. This radiation can be so intense, in fact, It can outshine all the stars in a black hole's host galaxy. Now, remember your favorite spaghetti dinner? Well, black holes have a unique way of serving up a similar dish, courtesy of a process known as spaghettification. Picture this. You're drifting towards a black hole. As you get closer, the gravitational pull at your feet becomes much stronger than at your head, stretching you out like a noodle. Not the most appealing way to become pasta, is it? But don't worry, this is unlikely to happen unless you're planning a trip to a black hole anytime soon. Perhaps one of the most intriguing effects of black holes is their ability to bend time and space. This is a consequence of Einstein's theory of relativity. In the vicinity of a black hole, the fabric of space and time is so warped that time slows down. That's right. If you could somehow hover near a black hole and survive, you'd age slower than your friends back on Earth. But here's the thing. It's not just about what black holes take, it's also about what they give back. Black holes can act as cosmic recycling centers. The material they don't consume is spewed back into space in powerful jets, seeding the cosmos with elements necessary for star and planet formation. Indeed, black holes are not just silent observers in the universe. They are active participants, continually shaping their surroundings. There's a fascinating theory that black holes could be gateways to other parts of the universe or even different universes altogether. Imagine, if you will, a cosmic tunnel, a shortcut through the fabric of space-time. This isn't the stuff of science fiction, but the theoretical possibility of what we call a wormhole. A wormhole, in its simplest explanation, is a tunnel with two ends, each in separate points in space-time. With a powerful enough force, like a black hole, these 2 points could be drawn together, creating a kind of bridge or shortcut. Now, this is where black holes come into play. The immense gravitational pull of a black hole could, theoretically, be the force needed to bring these 2 points of space-time together. It's like folding a piece of paper in half and then pushing a pencil through it. The shortest distance between 2 points isn't a straight line, it's a fold. But here's the catch. Despite the elegance of this theory, we've yet to find any concrete evidence that wormholes exist, let alone that they exist within black holes. Scientists are still trying to figure out if this is a plausible theory or just an interesting thought experiment. It's important here to remember that when we're talking about black holes, we're dealing with some of the most extreme conditions in the universe. The laws of physics as we understand them get twisted, contorted, and sometimes even broken. So, while we're far from confirming the existence of wormholes, the very nature of black holes makes them a prime candidate for such mind-bending phenomena. We're still at the threshold of understanding these cosmic behemoths. There's so much we don't know, so much we can't even begin to comprehend. But if black holes really are gateways to other parts of the universe, the implications are staggering. We could potentially travel vast distances in the blink of an eye, explore galaxies millions of light years away, or even glimpse into other universes entirely. While black holes might seem like the final frontier, they could also be the beginning of a whole new journey. We've journeyed through the enigmatic world of black holes, from their formation to their potential as cosmic gateways. We've delved into the birth of these cosmic phenomena, born from the death of massive stars and their various types, stellar, supermassive, and the elusive intermediate black holes. We've explored the effects they have on their surroundings, their gravitational pull so strong that not even light can escape. We also pondered over the tantalizing prospect of black holes as wormholes, potential shortcuts through space and time. It's truly mind-boggling to comprehend the complexities of these cosmic giants. Now we leave you with this question. Do you find black holes terrifying or fascinating? Share your thoughts in the comments below. Remember, in the vast expanse of the cosmos, black holes are just one of many mysteries waiting to be explored.